Hello, everyone. How are you guys doing today? I'm doing fine, thank you. How is the Ramadan going? Hard? So today, I think it's 12, right? 12 or 13? 13th. We have around 16 more. 16 to 17. Good luck. Did anybody try to upload the text correction on Brightspace? Okay, so if you haven't uploaded, please upload that text correction. You're going to get 10% of whatever you lost. And you need to go to a tutor, give me their email, their name, so that we can verify whether you really want it there. Yeah, sign part you can skip, but make sure to get their email and upload it by Thursday. And today I'm going to distribute you a test reflection. Once you fill that out, you're going to get 3 points more with your exam, plus your test correction. So you're going to earn 3 extra credits. Your exam, when is your next exam? Next week, Tuesday, exactly 1 week from today. So this week, we're going to decide up to which section our exam should be. We are going to do 10.2 today, and we will be able to finish 10.2. So in next 2 days, we are going to do chapter 6. How far? We are going to see. But I already posted the review sheet based on section 6.5 or something. Whatever we can finish this week, up to that point, our exam will be, and you can ignore the rest. And in our last class, I introduced you to all these rules. So we can skip all the details, but I'm just going to go over a little bit about all the parts. So chapter 10 talks about negative power and radical power. When we have a radical symbol, nth root of x, that n is called index or root. That radical symbol is called radical symbol, and whatever we have inside the radical, that thing we call radicand. So this is our radicand. The red one is the radical symbol, and the number inside the radical symbol is called index or root. Now, when we have radical, we want to convert that into exponent power because exponent power is easier to deal with. So in this conversion, this radicand turn into base for the fraction. Sorry, base for the fraction power, and the radical symbol turns into 1 over, and the index or the root turns into the denominator. So every part can turn into something. Radicand becomes base, the radical symbol becomes 1 over, and the nth root or nth index turn into the denominator n. Now, based on that, if you have square root of x, it turns into x to the power 1/2. If you have cube root of x, this x becomes the base, and the cube root turns into 1/3. So x, nth root of x means x to the 1 over nth power. So all these examples, we do not have any power inside the radical. Now the rule number 4 says, well, what if we have a number inside the radical? Well, if you have a number inside the radical, that power inside the radical turns into the numerator. So instead of 1 over, you write that power over, you index the denominator. So denominator, the index always is the denominator, always. If you don't have an individual power, numerator is 1. But if you do have an individual power on your radicand, then it becomes the numerator. Now, if your radicand is 0 or a positive number, then we can rewrite our nth root of x to the power m into nth root of x, and then everything raised to the power m. So these two are equivalent only if your radicand is 0 or a positive number. So when you simplify, if you take the radical first, the number will become smaller, and then you can apply the power, it will become a bigger number. So this is about radical to fraction exponent. The next one is about negative exponent. Anytime you see negative, this negative itself turns into 1 over. Just like the radical symbol turns into 1 over, the negative symbol on the power turns into 1 over. So negative power turns the entire thing as a fraction, where the radical turns only the exponent a fraction. So radical is exponent fraction, and negative means the entire quantity turns into a fraction instead of a whole number. So x to the negative 1 means 1 over your x to the negative 2, this negative turn into 1 over everything else on the denominator. So if we ignore the negative on the x to the negative 2, we left with x with the 2 power that goes on the denominator. X to the negative n means the negative turns into 1 over. So we left with x with the positive n power. That x with the positive n power goes on the denominator. So only the negative turns into a fraction 1 over, and we put the denominator everything else besides that negative sign. Now, if your fraction already has a fraction, if your power already has a fraction, it doesn't matter. This entire fraction goes in the denominator, where the radical symbol, the negative symbol, turns into 1 over. And if you have a fraction inside your power, sorry, on the base, if you have a fraction on the base with a negative power, we can easily turn this negative power into positive if you change the position on your fraction. So this numerator x goes in the denominator, and the numerator y goes in the denominator y goes in the numerator, and the power negative n turns into positive n. So a fraction turn into positive if you flip the fraction, the negative turn into positive power. And these are the last set of information, last set of exponent rules you have in this class. So I gave you 3 sets of rules. One is with whole number power, one is with 0, 1, negative 1 base, and this one is radical and negative power. Combining all these rules, do you remember how many points you're going to see in your exam? 35. You're going to see at least 35 questions. So at least 35 points on all these rules.
Well, wait, this is on the final exam?
I'm talking about the exam you're going to take next week, Tuesday. In the final exam, they don't ask for the rule. They ask how to apply the rule, like this type of questions. So the first one, we have 4 to the 1/2 power. So it looks weird. Let me rewrite nicely. This is same as x to the 1/2 power. Now 1/2 is what we're familiar with. So anytime we see 1/2, we can rewrite that into radical. Square root. 1/2 means you have square roots. Square root of 4. And we know what is square root of 4, right? What is square root of 4? Means what number when you square turn into 4. This is what you're looking for. 2. So answer is 2. The next one also has a 1/2 power. So anytime you see 1/2 power, rewrite using square roots. That will make your brain to work faster. So we have 1/2, 64 to the 1/2. 1/2 means square root. So the base 64 turns into radicand 64 here. And we know what is square root of 64. 8. Now the next one is a weird power. It says we have 64 to the 1/3 power. Now we are not familiar with 1/3 power. So do not rewrite 1/3 as a cube root. If you want, you can, but I would recommend no, because 1/3 is kind of weird. So anytime you see something unfamiliar, keep that unfamiliar thing. We don't want to mess our things up. Instead, rewrite the 64 base as something with the denominator power. Our denominator is 3. So what number to the 3 power gonna give us 64? 4. So you rewrite 64 as 4 to the 3 power. In other words, if you do that, the 3 power 3 denominator cancel out, and you're left with 4 base with 1 power. That means simply 4. In other words, 64 to the 1/3, which is cube root of 64, is just the number 4. So if you already know this from before, or you can figure this out in your brain, you don't have to show any of these work. From here, you can simply give me the answer 4, just like this. 64 to the 1/2 means 8. 4 to the 1/2 means 2. So if your brain can work this, if your brain can work this out inside your head, no problem. You don't need to show any stuff. However, anytime you have something weird on the denominator besides any number besides 2, you should do this, because later we're going to have more examples where our numerator is not 1 anymore. So you must rewrite to see all the things. Any question? Okay. Then we have a concept with negative. Do you remember the difference between negative 9 to the 1/2 and if I give you something like negative 9 whole thing to the 1/2? Now let me put a little bit space here. Negative 9 whole thing to the 1/2. Do you remember the difference between negative 9 to the 1/2 and negative inside the parentheses, negative 9 inside the parentheses to the 1/2? What's the difference between having a parenthesis and not having a parenthesis? Good job. When you don't have a parenthesis, it means you have a multiplication. So this one is same as negative times 9 to the 1/2. In other words, it's negative times square root of 9. And we know what is square root of 9, right? What is square root of 9? 3. So it's negative times 3. That gives us negative 3 as our answer. However, the bottom one says the entire negative 9 is your base. So find a number. What number, when you multiply 2 times, the result is negative 9? This is what they're asking. What number square gives you negative 9? 3 square is positive. So what number square going to give you a negative 9? Doesn't exist. If you pick negative 3 times negative 3 is positive 9. If you pick positive 3 times positive 3 is positive 9. There is no way you can multiply same number twice and the result will turn into a negative. This is impossible. So this one is impossible.
It's not gonna be the same for the first one, for the D, because -3 times -3 will be positive.
Yeah, but here your negative is a multiplication, not your base. And this one your negative is a base. So you have to find a number square, turn into negative. So the answer for this one is it does not exist. This is something unrealistic. This is something that is not possible in our real life. So that's why you have to be very careful. What is your base? Is it negative or is it positive? And then we have the next one. We have negative and then 81 to the 1/4. So what is our base? Negative 81 or only 81? Do you have a parenthesis? Only 81. This negative is a multiplication. Negative times 81 to the 1/4 power. This is what it means. Negative times that. Now, since this is a times, we don't have any problem. So we keep bringing it down and we rewrite our 81. This one is asking what number when you multiply the denominator many times and you get 81. Which number? 9? 9 times 9 is 81. You're looking for one number, multiply 4 times. 3. So you cannot use 9 square here. You have to use 3 4 times. So we rewrite our 81 as a 3 to the 4. And do you know why we use 3 to the 4 instead of 9 square? What is our goal to do? How do you simplify? You can cancel this denominator. Anytime you see denominator, you hate that, right? We all hate denominators. So you see this denominator, you think of a way to get rid of this denominator. So what we do, we rewrite our base using this denominator so that this power and the denominator cancel one another. So no more denominators and we are happy. We have negative times, what is our base? 3 and our power is 1. In other words, what is our final answer? Negative 3. So this negative is a multiplication. Our answer will be a negative number. If your negative is a base, we may have a negative number, we may not have a negative number. Any questions so far? So this type of question you're going to see in the final exam. And now the concept we did here, negative base, there is a rule actually. The rule says, if your base is a negative, but your radical or the root is an even number, the answer will always be impossible, undefined, doesn't exist. So negative 4 as a base, if you have an even number here, 2 is an even number, the answer, you don't have to do any math, it automatically doesn't exist. Why not? Because there is no way we can square a number and this turn into our base negative 4. It's impossible. Same thing, negative 16 as our base, so our base is a negative, and if you observe the denominator, this denominator is an even number. So basically they're asking what number when you multiply 4 times turn into negative 16. No numbers. It's impossible. So answer is doesn't exist. So this is another rule. Negative base cannot have even denominator on the exponent. So in the exam, I'm going to give one of these and said simplify. So you don't have to simplify anything as long as you indicate what is given. We have negative base, even degree, impossible. That's all you have to do. Indicate what you see and write the answer DNA. Don't exist. So even numbers are very scary. They cannot have any negative base. That's why the rule from -1, if you remember, I said -1 with even fraction, the answer is doesn't exist. We cannot have any negative base with even fraction. It's impossible to get an answer. See? But odd numbers are very generous. We don't care about what odd number. If you have odd powers, we may have a negative with the base, we may have a negative with the multiplication. It doesn't affect us. Odd numbers, odd fractions are always very generous. They always will have some answer, always, because they're odd. You know, odd people always have something different than other people. So, odd. Now, this is the type of question you're going to see in the final exam. The previous ones were too easy. Here comes the real final exam questions. The final. But in the in-class exam, you're going to see a few of these. Easy one, probably one of these, one or two of the negative rules, and then a few of these actual final exam questions. But yeah, to do the same thing what we did for the last few ones. You're going to rewrite the base based on the denominator. That's all. And then simplify from there. So we have 64. We are not going to write 64. We are going to write only the 2/3 power. And we are looking for one number. How many times to have 64? What our power should be? To the 3. Good job. Why are you picking 3? Why not 2? Denominator. That's their goal. What if for the denominator, our power should be that so that we can cancel? That's our goal. So what number, if you multiply 3 times, turn into 64? Two times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. So not 2, not 3. How about 4? 4 times 4 is 16. And what is 16 times 4? 64. So the 64 is actually 4 cubed. So we rewrite this as 4 cubed. So the 3 die, both of them. We left with what now? 4 on the base. And then 2 power on the exponent. So what is 4 square? 16.
When you work through the first part, or 4 cube, if you could get to 4 cube, do you lose points?
Then how are you going to cancel the denominator?
Oh, wow.
You want to see the power so you can cancel the denominator. That's why always rewrite the base using the denominator. 64 is also 9 square, right? Sorry, 8 square. But we did not use 8 square. Why not? Because 8 square doesn't cancel the denominator. Our goal is to always cancel the denominator. So use the denominator power to rewrite your base. And all 3 examples, they have the same power, just bases are different. In the second one, what is this negative? As a base or as a multiplication? Multiplication. Good job. So negative times something to the power 2/3. Now you already know it's 4 to the 3. What happens then? So what is left?
Negative times 4, yeah.
And what is our answer?
Negative 16.
Negative 16. So it looks same as the first one, but just because we have a negative in the front, now our answer is not positive anymore. It's negative of the 64. Sorry, negative of the 16. And now comes the last one. What is this negative this time? Is it base or multiplication? Base. So you're looking for one number. When you multiply 3 times, the answer is negative 64. So what number, when you multiply 3 times, turn into negative 64? Remember, anytime you multiply odd times, you always get an answer. So the answer is not DNA. It exists. What number? Negative 4. Positive 4 multiplied 3 times give you positive 64. Negative 4 multiplied 3 times going to give you negative 64. Negative 4 times negative 4 times negative 4 is negative 64. So we rewrite this negative 64 as negative 4 cubed. And on the outside, we already have our previously given 2/3 power. And then we follow the same direction as the last two. What happens now? Cancel out the denominators. Sorry, one denominator, one numerator. No more denominator. So what is left? Negative 4 on the base and 2 on the power. So what do we get? Positive 16. So our negative is not multiplication here. It's negative 4 as a base. So negative 4 times negative 4 are into positive 16. So all these are a little bit tricky because of the negative sign. So that's why I do like mine. Anytime you have a multiplication, keep multiplying them so you can see it's a multiplication. And anytime you have a base, keep using your parentheses to see that it's a base, it's not a multiplication. So parentheses tells us it's a base, no parentheses tells us it's a multiplication. Okay? Any question? So go ahead, enjoy the next 3. And let me take the attendance. It is a nice date. 3-3. 3326. It's like a little thing. 3-3. We have 3 twice, and that gives us 6. 3326. So we have that. Yeah. Okay, so attendance. Andrea, Sheikh, Christian, not here yet. Christina, Christopher, Danielle, Devlat, Dennis, Idaliz, Jared, Jay, Joshua, Justin, Kathleen, Kelly, Kyle, Lady, Muntaha, not here yet. Nayari, Nicholas I, Nicholas S, Aresti, Rana, Ricardo, Taj, Mora, and Zichi. So absent for now is Muntaha, Devlat, and Christian. Oh, and Andrea. Okay, who is ready for the first one?
Can I?
Go ahead, Mara.
So all we have to do is find a number that multiply 2 times give 4, so it will be 2 to the second power, so it will be cancel out with 2. So it will give 2 to the third, and the answer will be 8.
Perfect. Easy, right? Next volunteer. Nayari. Oh, sorry, 2 square, not 4 square. So multiply, and then what do you have? So negative times 8, which is negative 8. Andrea, right? No, never mind. Guilty leader. The last one. Volunteer for the last one. Lady. Good job. How do you know? See, all you have to do is look at the denominator, even, but what is our base? Negative. So they are asking what number, when you multiply twice, become the base negative 4? Is it possible?
No.
Impossible. So answer is doesn't exist. The easiest one. That's why when you rewrite, it's better if you see what they're asking, what number square is 4, and here also same thing, what number square is 4. So if you see what they're asking when you rewrite, you can see easily when the answer exists and when the answer doesn't exist. So denominator is telling us what number of the denominator power give you the radicand, and here it's a base. Any question? Was anything complicated or hard to understand? Okay, then try the next one. Just big, but it follows the same formula, same rules. What we are looking for here? What number to the 5 is 243? This is what you're looking for. What number to the 5 when I give you 243? So go ahead, figure that out. 3. Anytime you see big number, always start with 2. So let's see what is 2 to the 5. Means 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And what is 16 times 2? 32. So 2 to the 5 is not 243. And then you go to the next number, which is 3. And you do the same thing for 3 times. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. And lastly, 81 times 3, 243. 3 times 1 is 3. 3 times 8 is 24. So see, the answer is 3 to the 5 times. So in this class, when you see big numbers, don't get scared. Start with the smallest number and then keep going up to 7. Your answer definitely will be from 2 to 7 most of the time for the big numbers. Okay, so what do you do with this 3 to the 5? Jared, what do we do with this information? That 3 to the 5 is 243.
You have to basically do the same.
We have to rewrite this 243 using the information that is 3 to the 5.
It will be cancel out the denominator.
We have 4 to the 5 as a power. We rewrote 243 using the 5 power because of the denominator.
So that will be 3 to the 4 power equals 281.
Perfect. See, final exam and also in the in-class exam.
This is the same as.
So you take the root first and then you apply the power. Now comes another one with the division, but the same rule, same everything. Let me do the first step for you. Anytime we have, let's say, a over b to the nth power, what's the rule here? What's the exponent for fraction in the division in the base?
We have to multiply.
We have to distribute. So a to the n over b to the n. Applying the same rule here, the first step is 1 to the power 3/4 and 256 to the power 3/4. Now comes another rule. What is 1 to the any power? What is 1 square? What is square root of 1? What is 1 to the 0 power? 1. 1 to the anything, positive, negative, fraction, whole number, radical. 1 with any power is always 1. You're going to see this in the exam, okay? I'll give you 1 to the 100, 1 to the negative fraction, 1 to the decimal, 1 to anything. The answer is always 1. So what is our numerator here? What is 1 to the 3/4 power? 1. So numerator, you don't have to do any math. All you have to do is work on the denominator, simplify that. So go ahead, try that. What you're looking for here? What number to the what equals what? What power? 256. What number when you multiply 4 times, the result is the base 256. And 256 is a big number, right? So you start with 2. What is 2 to the 4? 16. What is 3 to the 4? What is 3 to the 4 on the next on the last page? 81. So what is next number? 4 to the 4. 4 times 4 is 16. And then 16 times 4 is 64. And now 64 times 4 is 256. See, I told you the answer will be definitely from 2 to 7. Figure out which one. So you rewrite your denominator is 256 as 4 to the 4 power, but you keep your outside power same, 3 to the 4. And then what happens? Cancel out the 4. So we have our 1 over, and now what do you have on the denominator? So 4 to the power 3. 4 times 4 times 4. 64. And this is our answer. We did the same thing as the last page, but this time it's a fraction instead of a whole number. Any question? So who is lost so far? The entire chapter, the entire section 10.2 is based on this. That's the main rule. That's it. So if you're lost here, let me help you guys before you go further. Is anybody lost? Anyone? Now we are going to do the same thing, but this time we have a negative power. And remember, negative power makes the entire thing a fraction. So if we have x to the negative power n, it becomes fraction x to the positive n. So negative turn the entire whole number into a fraction, while the radical turn only the power into a fraction. Negative makes the entire thing a fraction. So in order to do this, you have two choices. Either you work with a fraction by converting negative into a fraction, and then do same thing what you did in the last page, or first simplify and then convert the negative into a fraction. I prefer the other one, second method. First simplify and then turn this into a fraction. Because when you see fraction at the beginning, you already feel lost. So they are asking here what number, when you multiply 4 times, turn into your base 16. So we are going to keep the negative 3/4 power, but rewrite the 16 as something to the 4th degree. What number when you multiply 4 times? 2. So 2 to the 4 you rewrite as a 16. And then what happens? The power cancel out the denominator. We have 2 in the parentheses and negative 3 as the power. Now applying this power rule, what it becomes? 1 over 2 to the 3rd. And what is 2 to the 3rd? 2 times 2 times 2? 8. So it's a fraction 8, which is 1 over 8. If you don't have the negative sign, the answer will be whole number 8. Because of the negative sign, it's a fraction 8, means 1 over 8. So anytime you see a negative, remember your answer has to be a fraction. If you don't have a fraction, something is wrong, at least in this class. Negative means the final answer has to be fraction. Try the next one. Exact same question, but something is different. What is different? We still have parentheses. Okay, parentheses. I can put parentheses here, no problem. What else is different? Denominator. That means what you're looking for this time. What number to the what equals 16? What you're looking for?
Or to the second power.
We are looking for a second power. They switch their position. On the first one, we look for fourth power and base denominator. So base is 2. And this time, you're looking for 2 power. So base has to be 4. So go ahead, enjoy. And let me know what answer you get. My 2 here looks like a duck, right? Huh?
Of the negative 3 again.
This one?
Yeah.
So we have 2q, right? 2q. Now this negative means it's a fraction 2q. So fraction means 1 over 2q. Our answer is 8. Thank you. Question or answer? Which one? Answer? Okay, go ahead.
4 squared.
4 square with a negative 3 half power. Mm-hmm. 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 1 over 64. Which one is bigger? 1 over 8 or 1 over 64? 1 over 8 is bigger. So see, the denominator bigger, the fraction is bigger. The denominator is smaller, the fraction is smaller. Go ahead.
So how's it not 1 over negative 3? Why is it not negative 1?
The negative turns into 1 over. So whenever negative, it means 1 over.
Let me just take the.
Everything else besides the negative sign.
Okay.
So negative gives us 2 things. One is the symbol means 1 over. And if you ignore that negative, whatever left you have left to it goes on the denominator.
Okay.
I have a few more. Enjoy it, neighbors. And definitely a few of these will win the exam. And let me mark who came late. Andrea, still not here. Christian, still not here. Devala, still not here. But Muntaha is here. The 3 of them.
Imaginary to the fraction is 1 over.
So first simplify like the way we did. And then convert the negative into a fraction answer. Guys, you can talk with Nayari, your friend. Next to you. On the right side. You can talk with him. Be friends, guys. Make friends here. Enjoy this class. Enjoy. If you enjoy, if you don't understand anything, at least the class will be fun to be here. And do you know when you enjoy, you actually learn more and faster. What happened? Two negatives. But one is on the base and one is on the power. So they have different roles. So ignore the negative power on the negative on the power. Ignore that for now and simplify the rest. And then your answer will be a fraction. Don't give up just because it's a double negative. My PLTL leader, would you like to go around and help them? Would you like to go around and help the people you see lost? Don't be shy, guys. Come on. If you need help, just tell us. We are here to help you, huh? Okay. Give them two more minutes. Go ahead. Justin, right? Did you raise your hand to answer a question, or are you just stretching or stretching? Okay. Lady says she'd like to do C. So which one you like to do, D? And Joshua, I have more questions. You can do either one of these. I have two more. So pick the one. So the first one I'm gonna do, Lady gonna do. Second one, Justin gonna do. And then pick one of these guys for E and for F. So Joshua, which one you'd like to do? D, E, or F?
I'll do D.
Justin said he'd like to do D.
Okay. I think it's D.
E or F?
Okay. I'll do
Yeah. Then who would like to do E? Mara? D? D is already taken. Who would like to try E? Nayari? Okay. So 2 more minutes and then we're going to do. Lady is for C, Dusty is for D, Nayari E, and Joshua F. Okay? 2 more minutes. And then we're going to do them together. And all of these are final exam question, guys. Definitely you're going to see one of these in the final. One of this type. Take, no phone. Dustin, no phone, please. Ready? Lady, the first one. So how do you rewrite 8? What number to the what power? 8 is your answer. What number to the 3 power? So 2 to the 3 is 8, and you keep your -2 third power outside same.
And then we cancel the 3.
Mm-hmm. Mm-hmm.
One question. Can we have that in place of 1 coming down?
So this negative turn into a fraction,
And this 2 to the second power.
and we get 2 to the second power, which is 4. Positive. This is equal sign. Equal. The negative, the answer has to be a fraction. If you don't get a fraction, something is wrong. Justin, the second one. How do you rewrite 64? So you're looking for what number to the what equals -64? 3 to the what power?
-4 and
-4 to the power 3 is 64. And we have outside, cancel out the 3. -4 inside the parentheses. 1/-4 square. That gives us 1/16. Perfect. So see, just because it's a double negative, don't get freaked out. Keep one of the negative like invisible. Think of it as invisible. Simplify the entire thing. And then because of the negative power, the answer will be a fraction. So it's a fraction 16, which is 1/16. Which one? -4 to the -2? Which line? Oh, here, 3. So anytime you see your base in the denominator, the goal is to write the base equals what number to the denominator power. If you do this way, you can see when the answer exists and when the answer doesn't exist. You don't have to do it, but if you do it, it will make your life easier.
4 down, the 4 still stays negative under the 1.
Huh? What did you say?
So the 2 becomes positive, but the 4 still stays negative.
Yes, because this is -4 as a base. And the 2 becomes positive because it's power. Negative power means a fraction, the entire thing fraction. So they have different role. The negative on the base means multiply the base power many times. And the power negative on the power means make your result a fraction. Nayari, right? For E? We already did that before. So 3 to the 5. And we have negative. Perfect. We did the exact same question before with not the negative sign. So answer was whole number 81. But this time we have a negative sign on the power. So it's a fraction 81. Daniel, question? Okay, the last one, Joshua.
So to find the base of 256, I have to do 4 to the power 4, which brings it to 256.
4 to the 4.
And so now you can write it down as 4 to the power 4, parentheses, -3/4. And so you can now cancel out the numerator. And that brings it to, that brings it to 4 with a -3 exponent. So you could change that to 1/4, 1/4 to the exponent of 3. And so 4 to the exponent of 3 will be 64. So
64. Perfect. 1/64. We did the same for, no, we didn't. But if you don't have the negative sign, the answer will be whole number 64. With the negative sign on the power, it's a fraction 64. Any question? Now, we are going to use the exponent rule. When you have the same base, you're multiplying with multiple powers. We add the powers. So here we have x to the 1/3 multiplying x to the 2/3. If you observe, we have the same base x and multiplying with we are multiplying the bases. So how are you going to combine the power? So we add 1/3 plus 2/3. What is 1/3 plus 2/3? Do you have the same denominator? We do. So keep the denominator, and then we combine the power. This is 2. So we have 1 plus 2. That gives us 3/3. But what is 3/3? In other words, we have base x power 1. So we make the 1 invisible. It becomes only x. This will not be in the exam, but this will be in the homework. So same base, add the powers. If you already have the same denominator, just combine the numerators. If you don't have the same denominator, make them same. So all these examples are based on the rules, all the exponent rules. As long as you know your rules, you know how to start. If you find yourself lost in the first step, that means you don't know your rule well. So your job is to remember all these rules, put them together like I did in the review sheet, and keep looking at them every single day. So we have b to the negative 49 times b to the positive 29. What do we write? B to the negative 4 plus 2/9. We have the same denominator, so we combine the powers. And what is negative 4 plus 2? Negative 2/9. So b to the negative 2/9. But you cannot have a negative exponent. So what do you do? What is the final answer? Flip what? 1/b to the positive 2/9. So flip means you're turning it into a fraction. Instead of a whole number b, it becomes a fraction b. We cannot flip 9 and 2. 9 and 2, you flip if they are on the base, but they are on the exponent.
Anytime it's a negative number on the exponent,
and now building upon all this information, here comes our next final exam question. You'll definitely see one of these, and one from the before I said will be in the final. So we already know what to do, right? What do you think the first step is? We apply the rule number. If you have a b to the power n, what this rule is telling us to do? Distribute. So a to the n, b to the n. So we are going to apply this rule on the numerator as well as on the denominator. Both numerator and denominator, they have their individual power. So we're going to distribute individually. On the numerator, we have 4x to the negative 3. On the denominator, we have 6x to the 4. They have the individual power. So numerator gets the 3 power. And denominator gets the negative 2 power. And now comes the second rule. If you have x to the m and then n, what do you do with double powers? Multiple power means what? Do you add them? You have only one base, but multiple powers. See, multiple powers. The multiple reminds you of which operation? Multiplication. So same base, multiple powers means multiply them. So it's m x to the m times n. We are going to apply this rule here. We have same base x with multiple powers, multiply them. And 4 cube, okay, let's keep our 4 cube, no problem. 4 cube and x to the what power? Negative 9. 6 with a negative 2 power and x to the what power? Yes. Negative 8. And now do not do anything until you see all the negative powers are gone. We hate negative powers just like we hate denominators. So the simpler trick is switch their position, move them around, and then all the negative will turn into positive. We have a negative 9 here. Bring it down on the denominator. It will turn into positive x to the 9. We have negative 8 here. Move it up. This negative 8 will turn into a positive 8 power. This 6 has a negative problem. So move it up. It will turn into a positive 2 power. Now 4 with the cube. Does it have a problem? So if you don't have a problem, you stay same. If you do have a problem, you go to the other place. So after switching all these things, 4 with the 3 doesn't have any problem, so keep it. From the denominator, 6 has a problem, so we bring it up, and the 2 power turns into positive from negative. Now the numerator x to the 9, it has a problem, so we move it downstairs, and it becomes positive 9. Then on the denominator, 8 has a problem, so we bring it up, and the problem is solved. Every negative sign, switch them around, change their position, the problem will be solved. So that was our second rule. And then we have one more rule. In division, you have x to the a to the m divided by a to the n. What do we do in division? Subtract m minus n if it's a whole, if m is bigger. In other words, whatever is bigger, you keep that and subtract the smaller powers. So you see base here, x and x. So we have x to the 8, x to the 9. Let me highlight them. X to the 8 and x to the 9. Which one is bigger? So we keep our x to the 9 on the denominator. And we subtract the numerator 8. And the numerator, we don't have any variable, we just numbers. So we work with them. What is 4 cubed? 4 times 4 times 4? 64. And then 6 squared. 6 times 6? 36. And then you go to the math manually. 64 times 36. What is 6 times 4? 24. So 4 goes on the bottom, 2 goes on the top as an addition. 6 times 6 plus the 2. 37, 38. You left one position alone, and then you do 3 times 4. 12. So 2 goes on the bottom, 1 goes on the top as an addition. 3 times 6, 18, plus that extra 1, 19. And then you add down. What is 4 plus 0? 8 plus 2. 10 means 1, 0 goes here, 1 goes on the top as an addition. So we have 3 plus 1, 4. 4 plus 9, 13. Again, double numbers. So 3 goes on the bottom, 1 goes on the top. And then what is 1 plus 1? 2. Yeah, you really have to do this manually in your exam. You cannot use calculator. So our final answer is 2304 on the top and X is on the bottom. It's a lot, but you have to practice. You have 1 week time to practice all these things. Practice, practice, practice. I have a few practice questions here. So before you leave, try this and let me give you a reflection sheet. Once you fill out this reflection, you are going to get 3 points added with your exam, plus your test correction. If you do test correction and upload on Brightspace by next Thursday, you get 10%. That's the difference. 1, 2, 3, 4, 1, 2, 3. Bring this sheet next class. If you want to upload on Brightspace, upload it include your exam. Please answer this honestly. I'd like to know what happened to you guys. Since all of you failed. All of us. Huh? Yeah, we did exam. So no more physical copy, no physical copy for test correction. But if you want, you can keep a physical copy for this one. Okay. Next one. You can fill this out in next part.
I have a physical copy of it.
No physical test correction. Test correction should be digital, but the reflection, if you want, you can make it digital or you can submit in person.
So we could give it to you.
Only the reflection. So in our next class, we are done with 10, chapter 10, okay? We have few questions that will not be in the exam, but will be in your homework. And then not tomorrow, on Thursday, we are going to start chapter 6. So Thursday, Friday, we're going to do chapter 6, and we'll see how much we finish in chapter 6. Based on that, we are going to have your exam on next Tuesday. Okay, everyone? So enjoy your test reflection and the review sheet.
What if I didn't study?
You still have 1 week time to study.
Huh?
You still have 1 week time to study.
No, I'm saying, like, I didn't study.
Tell me you didn't study.
Okay. Like, the studying was, like, the PLTL.
Whatever you did, tell me that.
I just had the questions in PLTL.
Yeah, but how about the other things? Like,
No, I'm just saying,
tell me about,
just be honest,
when
right?
you didn't study, what did you do? Oh, I'm so sorry. I didn't notice that.
I felt one day.
So if you want me to do the test corrections in digital,
So you're already done with your test collection, right?
so
Take pictures, convert into PDF.
so you want me to like what's it called, compare it? You want me to compare the original
Or anything. So you have your oh wait, what did you say?
because I have my original work. So do you want me to take a picture of my original work and my
Make one copy. Okay. So the exam we have, whatever we get correct here, then copy those down.
I copy everything down? Okay.
To make a new exam solution, like entire exam
Do I
solution.
give it to you? Or do I also have to write it digital? I have this one.
Who put it with your exam?
Also, I do have to let you know that any set because I asked my
You know, they're not about the signature.
so that
I
was
understand.
okay. Thank you.
Uh-huh.
When the two tutors and then, and we have you, and we couldn't figure out what I did wrong on this one.
This is not wrong. The answer is 17.
So cause on the correction sheet, I copied it down the same too.
Yeah,
Because
the answer is 17.
we asked a few tutors and then we had.
Why did they mark it wrong? That's weird. So 44 and then plus 2. 45, 46. Let me post this. But how do you make this mistake?